Okay, so we're going to practice with some of our work, energy, and power equations. Not all of them. We're going to kind of build up on it, but we're going to use a few of them just to practice. So a horse is connected to a harness and pulls a wagon with 50 newtons of force for 25 meters. How much work did the horse perform? Okay, let's think about that. And in my given, I'm going to have 50 newtons. I know newtons. I look at my units table. I say, oh, that's force. So F equals 50 newtons. And then I see 25 meters. And I know that's some sort of distance. So let's put it as D equals 25 meters. My unknown is right here, which is work. I know the letter for that is W. So my equation is work equals force times distance. It's already solved. So my solution is simply going to be W equals 50 newtons times 25 meters. I pull out my calculator, and that comes out to be 1,250 Newton meters. But remember, a Newton meter is a joule. So let's put it as joules. You could put either one, but let's put it as joules. Done. Nice and easy. We like these. Okay, number 2. A 40-kilogram girl chases a cat upstairs so she ends up 5 meters above the ground in 30 seconds. How much power did the girl expend as she ran after the cat? Okay, so got this staircase, and we've got this girl, and she's going to run up after her kitty cat, and she's going 5 meters up in 30 seconds, and she is 40 kilograms. So in my given, I know kilograms is mass, so M equals 40 kilograms. And now this 5 meters could be distance, or it could be height. Because I'm dealing with energy, I could do either one. I'm going to put both just in case so I can figure out which one I want it to be. So it could be either one. And I know time is 30 seconds. And my unknown is power. So my equation for power is work divided by time. And my equation for work is force times distance. Okay, so then maybe I could use D. But this is mass. But do you remember how we can change mass into force? I just got to change this into newtons. How did we do that? We just multiplied by 10 because it's the force of gravity. So that means I do know that force of gravity is equal to 400 newtons. So I could use that for my force. And then I can use the equation. So solving, I'd end up taking this and putting it there. So we end up with power is equal to FD over T. So then when I plug it in, P is equal to, let's move this up just a little bit, is equal to 400 newtons times 5 meters divided by 30 seconds. So I plug it in. 400 times 5 divided by 30, and I get, let me move it over a little bit, and I get 66.7. The question is, what are the units? So I look on the top and I see Newton meters per second. Newton meters over seconds, which is the same as a joule per second, which is the same as a watt. So I know it's 66.7 watts. Okay, look at all the information we had here. You should have. Let's try number 3. What is the girl's change in GPE? Okay, so we got to go back and look on your paper. So the mass didn't change. Her mass is still the same. It's still 40 kilograms. And remember, we have the D, or the H, is equal to 5 meters. And our unknown this time is GPE. And I can do GPE is equal to mgh. Now I want you to notice, don't just do this blindly. mg, oh, remember FG is equal to mg? So that's still, right, this equation is still m, so mgh is the same as F times D. They're exactly the same because they're both energy. It's just a different way to look at it. But let's do it as mgh. But keep your thinking caps on when you're doing this. So when we solve it, we end up with GPE is equal to mgh. It didn't change. I guess I could put the S there. So now GPE solution is equal to 40 kilograms times G, which of course we know is 10 meters per second squared, times 5 meters. Of course, you can use 9.8 if you really want to. So 400 times 5, 2,000. Could plug in your calculator if you wanted to. Well, what are the units going to be? Well, it's that crazy thing, right? Kilogram meters per second squared. Okay, so it's kilograms meters squared per second squared, but we know that's a Newton meter, and we know that's a joule. The units are the craziest part of this. And you could just trust it and just say, oh, I know GPEs and joules, but it's nice to see where it comes from. Okay, let's try the next one. How much work did she do? Oh, okay, let's try it a different way. There's lots of different ways you can do it, but I just want to show you what we can do. We know that power is equal to 66.7 watts, and T is equal to 30 seconds. And again, this is not the only way to do this problem. I just want to show you a different way, right, that we haven't done before. And the unknown is work. And the equation is power is equal to work over time. So then I can just simply multiply both sides by T. And I end up with the solved equation of work, because that's the only thing left over here. Work is equal to power times time. So my solution is 66.7 watts times 30 seconds. 66.7 times 30. What is that? It's not going to be exactly the same number we got before. 66.7 times 30. Because of rounding, that comes out to be 2001. But notice that's almost the same as my GPE. It's pretty darn close. If I didn't round, it'd come out exactly. What are the units? Well, let's see. A watt is a joule per second. I told you the units are crazy. Times a second. That cancels. I'm left with joules, which makes sense. So they're about the same. You know, in physics, we don't need to be exact. It's about the same as it was in the previous problem. And that's it.